Okay, starting on page 5, we are working on these, we call them link sheets. Link sheets are just linking up different representations, looking for representations of inverses and how they relate to each other. So we're starting off with an equation or a rule. Function h is defined as 2 times x plus 3 to the third power. And so we're trying to figure out the inverse. And when we're done, the inverse notation function will look like this, but let's see how we get it. So if we're using the word form, we'll take function h and work with our inside-out method of defining what the function is doing. So the first thing that happens to x is we're adding 3. So that's first on the list. Then we're cubing that quantity, and then we're multiplying it by 2. So we make that list, and then we invert that list with opposites. So whatever was last comes first. We divide by 2 to cancel multiplication. Then we cube root to cancel cubing, and we subtract 3 to cancel addition of 3. So when we write that final function, we start with the division by 2, that's the x over 2 part. Then we do the cube root, and then we subtract the 3. So that's the word form. If we want to look at it in an algebraic form, then we can start by changing that h of x to a y. And then the next step would be to switch the x and the y. And now we're going to try to solve for y. So we want to divide by 2 to isolate the y quantity. And then we can cube root to isolate the y plus 3 quantity further. And so a cube root is going to cancel a cube, and that entire x over 2 fraction has a cube root on it. You notice that I switched the sides here, and that's because we want y to be on the left eventually. Then we take after it's been cube rooted, that cube goes away, and all we need to do then is subtract the 3. And so we have our h inverse function using the algebraic method. So word form or algebraic will work for most functions. So in the graph, the smiley faces represent the original graph. I looked at the equation, looked for shifting. It saw a left shift of 3 and no vertical shift. So that's why my first center point is at -3. And then it's times 2. So instead of going 1, 8, 27, it would go 2, 16, and 54. So I just go up 2 for that first one. And then it's going up super fast from there. And it's down 2 and then going down from there. So we know that inverses are symmetrical over the line y equals x. So y equals x is here. And we can just simply count the distance across perpendicular on a slope of -1. That's one way to find those points. Or we could switch the coordinates. So if I have a point at -4, -2, that's this first point here, I can just switch it to -2, -4 and plot it. So you can either use the coordinates or count perpendicular slopes across the other side of the line. Once you have those established, then you can connect them and make your curve. The more points you have, the better the curve ends up being, the more accurate your graph is. And we just label it with the original h of x and then the h inverse. So you can pause here and make sure that that graph looks the same as yours. All right, then we have a table format. And so I've made a table where it's kind of centered. So if you think about the -3, 0 was that first anchor point here. And so the next 2 points before it would have been -4 and -5. The next 2 points after it would have been -2 and -1 along the x-axis. So we know the pattern goes normally 1, 8, 27, but here we're going 2, 16. And so -2, -16 on one side, +2, +16 on the other side. So if I want to change the table from the function table to the inverse table, all I need to do is simply switch the numbers. So whatever was x becomes y, and whatever was y becomes x. Inputs and outputs just switch. And that's the way the rest of this table looks. So it's pretty easy to generate points just by switching the numbers from input to output. So the relationships between the functions and the undo rules. So we have in table format, we see the x and the y values are switched. In the graph, we show a line of symmetry at y equals x. And so all the points are reflected over that line. And in the equation check, if I take any point or any value and plug it in as an input to function h, the output that I get when used in the inverse function should take that back to the original input. So by using 0 and getting 54, that should tell me that if I use 54 in the inverse, I get 0 as a result. And that's what happens. You can follow those steps. So cubing the 3 gives me 27 times 2 is 54. Now 54 becomes the input in the inverse function. Divide first, get 27, cube root, get 3, subtract 3, get 0. So what should happen is the input of the first function becomes the output of the second function. They're just undoing each other that way. All right, so again, you can pause and try to process if there's something that didn't quite make sense on that page. All right, on to page 6. This is an even easier function to use just because it's linear. So the algebra format here says to take f of x and make it a y, switch x and y, and then isolate y. So if I add 6 and divide 3, then I have x plus 6 divided by 3, or you can distribute that division and call it 1/3 x plus 2. Either way is an acceptable way to write that inverse. And you notice the inverse notation, f inverse of x. So on the graph, the smileys again represent the original line at -6, slope of 3, and the stars would be the reversals. So if a point is on the reflection line like 3, 3 is, then it's not going to move. But any point that's off the reflection line will come across. And so my inverse is graphed here. So you can do it just by plotting those points and reflecting them. Notice I skipped the word form here, but the word form would be pretty simple to do too. So step 1 would be times 3, and step 2 would be -6. So in the inverse, step 1 becomes +6, and step 2 becomes divide 3. So it works out either way. All right, table format. So you can just list off a bunch of x values and get the corresponding y values, and what should happen is they should switch. And so you see that each of these lines is just the opposite of the original, switching inputs and outputs. So again, the table switches the x and y values. The graph is showing a line of symmetry at y equals x with points coming across perpendicular. And then the equation check, if I use 0 as an input, I get -6 as an output. So then if that output becomes the input, -6, I get 0 as the output again. So they're undoing each other for that reason. All right, we'll do more with these in class, but this should give you a good introduction, a good foundation to start this section.